Welcome back. For this video, we're providing a deep dive into the key considerations when constructing multi-level basements. And the concepts relate to anything from a two-level basement right down to, let's say, a 5 or a 6-storey basement, which from time to time do occur, particularly within high-end areas within London. So, firstly, we want to focus in on the construction methodology for the liner walls. What we have here on this typical detail is the hydrocrete watertight concrete being demonstrated as being cast within the top 300mm of a monolithically cast slab, and then there's the liner walls which will be cast at a minimum of 200mm. Now, the methodology of casting the walls can differ depending on the construction method. What we're demonstrating here, we're going to just zoom into the interface of the intermediate slab. We're demonstrating how a liner wall is cast to the underside of the next floor level. By casting in this method, we are introducing two construction joints. As you can see, firstly we have the Hydrostop BR, which is a hydrophilic water bar being installed on top of the liner wall. And there is then the Semflex VB, which is a steel blade water bar being introduced within the kicker that's cast in line with that slab to receive the future upper level wall. Alternatively, it's key for contractors and indeed structural engineers at an early stage to consider whether there is an opportunity to cast the liner wall to a higher level, i.e. to the position where the Semflex VB is currently shown. The connection interface then between the liner wall and the intermediate slab for reinforcing would be by the use of quicker strip or a continuity reinforcing strip of some kind. By introducing this detail, it limits the number of construction joints and therefore limits the risk of water ingress to the basement environment. Now, most multi-level basements, these are definitely high risk. These are certainly considered as a high risk area of waterproofing for us as a manufacturer. It's key to consider the importance of introducing a cavity drain system. High risk basements, which tend to have high water tables, it's key to understand how we're going to maintain the basement environment for the duration of the life of the structure. By including a cavity drain system, which is fully maintainable, it ensures complete compliance with BS8 102. So by turning on the HydroFlow HP layer here, we can demonstrate the key interfaces that we need to consider for. So firstly, we're going to take a look at the intermediate slab. A really key principle for us to understand is that at every level of basement, a maintainable perimeter channel in the form of hydro channel should be included to the perimeter of the structure. This is a requirement of BS8 102, that we can maintain the cavity drain system at each level of the basement. Now, in terms of the drainage of the water, this is typically incorporated via casting in 40mm pipes, often known as weep holes, at 1 metre centres around the intermediate slab. This will then enable the water to flow from upper levels to lower levels and ultimately draining to the lowest point of the basement, where the water will then be directed to a sump pump and pumped away from the structure. It's also key to bear in mind that at the intermediate slab, and indeed at the soffit of the ground floor slab, that a suitable cementitious coating is applied as a 1 metre strip within this zone. Because the cavity drain system obviously doesn't pass through this element of structure, and it's important, if we're to create a grade 3 environment, that two forms of waterproofing defence are included. Now, a key principle to bear in mind is that water will not track through well compacted concrete via capillary action more than 1 metre. Therefore, the inclusion of a suitable cementitious waterproof coating to the soffit of slabs and to the top of slabs, as we can see here at the intermediate slab level, will help to eliminate the risk of any moisture tracking within the structure. And finally, we'll just move to the top of the basement. It's always very key with any design that there is complete continuity from the underside of basement slab right up to your DPC level. As we can see here, we've got continuity continuing from the upper level of the capping beam through the top of the capping beam and then via a self-adhesive membrane to connect with the DPC at ground level. Hope this video has been helpful for you. Some key takeaways for you are to consider about, is there a better way to construct our liner walls to limit the number of construction joints into the basement via the means of a quicker strip type detail at intermediate slab levels. Trust this has been helpful, and we'll see you back next time.